Let's have a look at a typical exam question that occurs from time to time. You may be asked to work out something like 1.1 to the power 6 to 2 decimal places. Obviously you're not allowed to use a calculator. Obviously you're not supposed to work out 1.1 times 1.1 times 1.1 and do it as a long multiplication sum. That would be ridiculous. It would say in the question by using the binomial theorem, and this sort of thing would be part B perhaps or part C of a bigger binomial question, so it would be obvious you had to use the binomial theorem. So what would I do? Well, you need to write it as a bracket with two terms, which is binomial. Bi means two terms inside the bracket, raised to a certain power. So in this particular case, I would write 1.1 to the 6 as, well, I'd say it's equal to 1 plus 0.1 inside a bracket, that makes 1.1, and raise the whole bracket to a power 6. So what we've got is a binomial expansion, but instead of having the normal x involved that we normally have, we've got just two numbers involved. The mathematics of this is exactly the same, however. All we're going to do now is expand that out in the normal sequence of events. So here we go. 1 is the first term, so it's going to be 1 to the power 6 plus 6 choose 1, 1 to the power 5, and then we have 0.1 to the power 1, plus, then we have 6 choose 2, 1 to the 4, and we have 0.1 squared. Now be aware that we're only going to two decimal places, so I do not need to expand out the full expansion. You only need to expand out as many terms as is going to affect the second decimal place. Well, if you were to think about it, 0.1 if you square it gives 0.01. So when you multiply it by this 6 choose 2, it will have an impact upon the second decimal place. So we need to carry on. So plus 6 choose 3, and then it's going to be 1 to the power 3 now, power from 4 to power 3, and then it's going to be 0.1, and it's going to go to a cube. Well, if you look at this, 0.1, if you cube it, it's 0.001, and then you have to times it by whatever that is. Then I think that is as far as we're likely to need to go, because we only want the answer to TDP, and that's 0.001. So it's possible that this term here isn't actually going to affect things, but I'll work it out just in case it does. Plus, I definitely won't need any more because the decimals go too small. So here we go then, it's 1 to the power 6, which of course is just 1 if you like, plus 6 choose 1 is 6, times by 1 is 6, times by 0.1 is 0.6, plus, then you have 6 choose 2, well that's 6 by 5 over 2 by 1, 6 by 5 is 30 over 2 by 1, that's 15, I'll actually work this out in stages, times by 1, so that doesn't change anything, 0.1, if you square it, you get 0.01, plus 6 choose 3, that's 6 by 5 by 4 over 3 by 2 by 1. If you want to do it at the side, excuse me, and then you can cancel 3 2s are 6 with the 6, so 5 4s give 20. So that's 20 times by 1, and then times by 0.001 is what you get if you cube the 0.1. Plus, and then dot 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 dot. Okay, so we end up with 1 plus 0.6 plus 15 times 0.01 is 0.15 plus, and then 20 lots of that is going to give you 0.020 or just 0.02. You can see that this one here has got a value to two decimal places. If I'm not sure that that is as far as I need to go, then work out the next one. And just to satisfy your own curiosity, make sure that you go to as many decimal places as required. In this case, plus, if you do the next one, it doesn't have any impact on the second decimal place. But if you're not sure, multiply it out and see if it does. Okay, so for that one there, I'm just going to say plus dot 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 dot. So we're going to say 1 plus 0.6 plus 0.7 plus 0.15 plus 0.02. If you add them all up, you get 1.77 to 2 decimal places. And if you have a calculator when you're watching this video, you can check that yourself. If you put 1.1 power 6, press equals, it will give you that to 2 decimal places. And there you go. That's a typical exam question, making use of binomial to work out an awkward decimal power calculation. On this little short video, I'll do one more very similar to that. And in this case, for the second question, instead of 1.1 to the power 6, what I'm going to do this time is I'm going to say 0.9 to the power 8. And I want it again to 2 decimal places, like so. Well, once again, I'm going to write this as a binomial expansion to a power. So I'm going to say that this is some binomial, obviously to a power 8. Now, to be honest, you can actually write whatever values in here that you like. I didn't mention this in the previous question, but perhaps I'll backtrack and have a look at that in a second again as well. So, for example, I could put 0.5 plus 0.4 to a power 8 and work it through like that. But if I was doing that, I wouldn't be using my common sense, because these are really awkward figures to use. If you can, always try and make one of the figures in here to be equal to 1, because then it becomes much easier to work out, because 1 to any power is just 1. So that would be a ridiculous choice. Okay. I would probably say the easiest way to do it is to take 1 and then subtract 0.1. That would be the best way to make a 0.9, I would suggest. I wouldn't do it any other way. That is going to be the easiest to work out. So if I expand through using the binomial expansion and just go as far as I need to go to get the answer to 2dp. So first term, 1 to the power 8 plus 8 choose 1, 1 to the power 7 times by, now be careful, it's minus 0.1, so you have to put minus 0.1 to the 1, plus 8 choose 2, 1 to the 6, minus 0.1 squared, plus 8 choose 3, 1 to the 5, minus 0.1 cubed, plus, if you're not sure, keep going, 8 choose 4, 1 to the 4, minus 0.1 to the 4. That would definitely be more than enough, that one there, because that one there is going to give you 0.0001, which is 4th decimal place involvement. So it doesn't matter what you times it by, that figure there is not going to take it to 2 decimals. So I doubt very much whether that'll be involved. And I'm certainly not going to bother with the rest. So here we go. This is 1 plus, that's 8 times 1 times minus 0.1. So okay, I'll get rid of the plus, it's actually going to be a minus 0.8. And then we've got 8 choose 2. Well, 8 choose 2 is 8 by 7 over 2 by 1, that's 56 over 2, that's 28. So I've got plus 28 times, and if I square that, be careful, it's a minus, you square it, you get a plus 0.01. Plus, and then 8 choose 3, well, side sum, 8 by 7 by 6 over 3, 2, 1. 3, 2, cancel with the 6 to give 8 sevens, 56 that is. That's 56 times 1, and then you've got to times it by negative 0.1 cubed. Well, if you cube a negative, you get a negative, and then 0.1 cubed is 0.001, like so. Plus, well, I said to you that the next term is very doubtful whether it's involved in the calculation or not, because the decimals go too small. But if you're not sure, let's do a side sum. 8, 7, 6, 5 over 4, 3, 2, 1. 3 and 2 cancel with the 6, and then 4 into 8 goes twice. 2 5s are 10, times by 7, 70. So 8 choose 4 is 70, times 1, times this, which, well, it's back to positive again, and 0.1 to the power 4 is 0.0001, plus, and so on. Fine. Let's just tidy up, and let's see what we get. So we end up with 1, take away 0.8, plus 0.28, that times that is 0.28. Then it's a minus again, minus 0.056. That times 56, 0.056. And then plus again, And if you take that times by 70, you're going to get 0.0070 or 0.007. And then of course it would be minus and so on. So we're going to work out this calculation now. So you're going to have 1 take away 0.8. Okay, that's 0.2. 0.2 plus 0.28, that's 0.48. 0.48 take away that. Now some of you might not be happy to do that in your head. So okay, do a side sum then. 0.48, put an O on the end, 0.480, subtract 0.056. 0 take 6 you can't do, borrow 1, 10 take 6 is 4, 7 take 5 is 2, 4 take 0 is 4, so you're getting 0.424. You can see third decimal place involvement. Okay, third decimal place involvement there. If I add a 0.007 to it, okay, so if I'm now adding the 0.007, I don't think that's going to have any effect on things. 4 and 7 is 11, carry the 1, 3, 4, so there you go, 0.431. It's not going to affect things greatly, but what you'll notice is this fourth, 1, 2, 3, 4, this fifth term here, okay, this 0.007, okay, initially you thought, I thought it wouldn't affect things. Times it by 70, it goes to the third decimal place. And when you add it on, can you see if I hadn't added it on, it would have been 0.42 to 2 decimals. But by adding on this last 0.007, it's gone to 0.43. So in effect, even though I thought it wasn't going to affect things, in this occasion it has affected things. So you've got to be really careful about it. So the answer is equal to 0.43 to 2 decimal places. And if you hadn't have added that one on, it would have been 0.42. So be very careful. In other words, always work out perhaps one more term than you think is needed, just in case it does affect that last decimal place. Okay, I hope I didn't confuse you with that, because I was tempted to leave that out. In the previous one I did leave one out. I left it out because I knew it didn't affect anything. If you try it, it doesn't affect anything. Perhaps I shouldn't have. Perhaps I should have expanded or multiplied that one out and showed you it didn't affect things. But there you go. 2 typical examples working out a number, a decimal number to a power using the binomial theorem to work it out. That's the end of this short video.